Welcome to this visual guide to Azure Virtual Network. Here we explore the core ideas behind building secure, connected, and scalable networking in Azure. Think of VNet as the foundation that supports application communication, data movement, administrative access, and hybrid integration across modern cloud environments. Throughout this guide, you will see how address planning, subnet structure, connectivity models, security controls, routing behavior, private service access, DNS patterns, delegated services, and operational governance all work together. The goal is to turn technical networking concepts into a clear visual story that helps architects, engineers, and leaders understand both the design principles and the practical value of Azure VNet in real enterprise scenarios. Azure Virtual Network is the private networking layer inside Microsoft Azure. It acts as the logical boundary where cloud resources communicate with control and isolation. Within a VNet, organizations can place virtual machines, applications, databases, and supporting services into a network space that behaves much like a traditional data center network while still benefiting from cloud scale and flexibility. Teams can define address spaces, create subnets, apply security controls, and connect workloads to external destinations in deliberate ways. That is why Azure VNet becomes the starting point for almost every serious Azure architecture. Designing a strong virtual network begins with thoughtful IP address planning because early choices have long-term consequences for growth, connectivity, and manageability. Teams start by selecting a CIDR range that supports current workloads while leaving room for future regions, new applications, shared services, and gateway requirements. That larger space is then divided into smaller subnets that separate functions such as web tiers, application tiers, data zones, management services, and platform integrations. One of the biggest goals is avoiding overlapping address ranges because overlap can block feature pairing, VPN, and express route scenarios. Good planning makes the environment easier to grow and much easier to troubleshoot later. Core connectivity inside Azure VNet is about making sure the right resources can reach each other over the right paths with the right level of exposure. Resources inside the same virtual network can usually communicate by default, which allows application tiers to interact efficiently. Outbound internet access can be provided in a controlled way using managed egress patterns such as NAT instead of broad public exposure. Administrative access can be handled through options like Azure Bastion, so remote management does not depend on unnecessary open ports. Hybrid connectivity back to on-premises environments can be added with VPN or ExpressRoute depending on performance and business needs. The goal is balance, useful connectivity without loose governance or unnecessary exposure. Security controls are central to Azure networking, and network security groups play a major role in deciding what traffic is allowed and what traffic is blocked. NSGs evaluate flows based on source, destination, port, direction, and protocol, giving teams a practical way to segment workloads and reduce unnecessary exposure. They can be applied at the subnet level to influence groups of resources or at the network interface level for more targeted enforcement. A strong NSG design often follows application tiers, so web components, application services, and data stores each have clear boundaries and approved paths between them. Good segmentation improves both safety and clarity. Routing determines where traffic goes after it leaves a workload, and Azure provides both default behavior and advanced options for shaping that path. Every subnet starts with system routes that allow basic communication within the virtual network, toward Azure services, and toward external destinations. When organizations need more control, they can use user-defined routes to override defaults and direct traffic through specific next hops, such as firewalls, virtual appliances, or hybrid gateways. In more integrated environments, BGP can advertise routes learned from connected networks. Effective routing becomes especially important in hub and spoke topologies where inspection, segmentation, and centralized egress are often required. Clear routes produce safer and more explainable traffic flows. Private access to Azure Platform Services can be achieved through two important patterns that improve security and reduce dependence on public endpoints. Service endpoints allow selected subnets to reach supported Azure services across the Azure backbone while still using the service's public endpoint model from an application perspective. Private link goes further by creating a private endpoint inside the customer network so the platform service appears through a private IP within the VNet itself. Both methods reduce exposure to the public internet, but they serve different architectural needs. The right choice depends on how much isolation is required, how the application behaves, and how the team wants to manage connectivity to shared Azure services. VNet peering is one of the key features that allows Azure networking to scale beyond a single virtual network without sacrificing performance. Peering connects separate VNets over the Microsoft backbone with low latency, which makes it useful for linking application environments, shared services networks, and regional deployments. It is a common foundation for hub and spoke architecture, where security services, DNS resolvers, or centralized egress patterns sit in a hub and multiple workload networks connect as spokes. Peering can cross subscriptions, tenants, and regions, which gives large organizations significant flexibility. At the same time, peerings are not transitive, so teams still need to model topology carefully and understand where direct peerings or additional routing constructs are required. Name resolution is a critical but often underestimated part of network design because applications depend on reliable naming just as much as they depend on raw IP connectivity. In simple environments, Azure provided DNS may be enough to help workloads discover each other inside a virtual network. As architectures grow more advanced, teams often introduce Azure DNS private zones to support private naming across services and environments. They may also use Azure DNS Private Resolver or custom DNS forwarders for hybrid scenarios where on-premises systems and Azure resources must resolve names across boundaries. Good DNS design makes cloud networks easier to operate, easier to scale, and far less frustrating to troubleshoot. Some Azure platform services need a dedicated delegated subnet so they can integrate cleanly with virtual network controls while still applying service-specific intent. Subnet delegation reserves a subnet for a supported managed service and allows Azure to understand how that service should behave in the network. This makes it possible for managed services to participate in enterprise network designs without forcing teams to abandon broader governance or segmentation practices. Administrators can still think carefully about surrounding routes, security groups, and placement while giving the managed service the space it requires. Delegation is less about surrendering control and more about enabling safe service integration inside a governed architecture. Operating a virtual network effectively requires more than creating subnets and attaching resources because long-term success depends on visibility, governance, and disciplined change control. Teams need to understand effective routes, observe traffic behavior, enforce standards, and ensure that only the right people can modify critical network settings. Monitoring tools and route inspection capabilities help reveal what the network is actually doing rather than what the design was assumed to do on paper. Policy-based governance can keep configurations aligned across subscriptions and regions, while role-based access control limits accidental or unauthorized changes. These operational practices become more important as environments scale and interdependencies grow. Azure Virtual Network brings together the essential disciplines of cloud networking into one coherent foundation that supports growth, control, and resilience over time. Across this guide, you have seen how careful address planning, subnet structure, connectivity management, traffic security, route design, private service access, reliable DNS, managed service integration, and operational governance all contribute to stronger outcomes. None of these areas stands alone because each one affects the flexibility and safety of the others. When organizations approach Azure networking as a design system rather than a checklist, they are better positioned to support application modernization, regional expansion, and hybrid integration with confidence. The closing message is simple. With the right patterns and operating discipline, Azure VNet becomes a dependable platform for long-term enterprise cloud architecture.